Okay, hello and welcome to the first lecture that we'll be giving in this series for this tutorial. Hello and welcome for the first lecture in the series for this tutorial. My name is David. I'm one of the organizers of the Acoustically Aware Robots tutorial, and I'll be giving a short overview about the activities that we have planned for you. Very important, please check back on the main website as we will be updating the material over the next few days. The material will also stay online past HRI. And then finally, do come to our Discord and discuss with us there if you have questions, if things are unclear, or if you found bugs or errors or any sort of thoughts you have. We'd really like to hear them. So this is what the Discord is for. I'll be there online most of the time, and so we can then go from there. So the first part of the workshop is focused on active listening, basically focusing on the idea of if you consider that your robot suddenly has the ability to listen to contextual sounds, so not specific things, not like words or language, but much more contextually, so it can understand that the door was opened or closed, or that someone is talking, or that maybe multiple people are talking. The question is, if once we have this capability, what are the kind of things that we would want the robot to do? And what are the kind of things that we would want the people to understand? Like, what kind of impact does this have on the interaction between people and robots? And what can it be used for, besides sort of initial ideas? Just quickly about the team. So my name is David Gödecke. I'm a PhD student at Cornell Tech, and I'm a student from Professor Zhu here as well. And this workshop is developed together with her. So what will we be covering today? So or for this presentation in particular, what is an acoustic interaction? What are the kind of things and examples that we've seen in the world already, just to understand what the capabilities of these systems are? How to use the worksheets, and how to think about the design from how the worksheets are designed and how to use them. Then we will go through some sort of technically how do these things work, and I will also talk a little bit about where you can find the technical prototype exploration, so where you can find our example code so that you can experiment with stuff yourself. So at the end we have a GitHub page where we have examples where you can use where we have a basic classifier that can either distinguish 4 or 10 classes of sounds, and you can play around with that and see how well that works for you, and you can understand what the capabilities of such an algorithm are, and sort of basically use it as a design material. Right. So one of the first examples that I wanted to talk about is this sort of an application like this is this prototype from the Fraunhofer Institute in Germany, where they're using these acoustic sensors or microphones to capture external noise. One of the examples that they give is basically saying if there's an ambulance driving, you can hear this ambulance way before you can see it. And so if you give your car the ability to hear things, maybe even, with array microphones, locate where a certain noise is coming from, you can actually generate a very precise understanding of your environment, especially sort of for traffic. This can be important. And so this is one of the examples where you use, it's not the specifics, you don't care which siren specifics you hear, but you want to know that you hear a siren, and that already gives you a lot of information on how to behave in the future, especially for an autonomous vehicle. To maybe, wait until you see the ambulance before you start moving into an intersection or something like this. So it can have a lot of value already in the autonomous vehicle context. Another example is the sound recognition now offered in the newest version of iOS. So in this picture, we show basically how this notification looks like, as well as the settings that you have on the very right. So this shows 3 different iPhone screens. The link is sadly not visible. I will make sure that the link is in the description. It's a picture from 9to5Mac. And so we can see that you basically, as soon as it detects a sound, it will notify you, and you can basically take action upon that. You can snooze it or dismiss it. And the kind of sounds that it can detect range from like fire alarms, sirens over animals, cats, dogs, to household appliances, and like people noises like a baby crying. And all of this basically can help a person who is hard of hearing detect and react to certain sounds that we normally would do generally for people, compared to people who don't have a hard time hearing. And so, yeah, here these are those kind of this is sort of the same kind of technology in like very distinct classes, right? So this is not speech and detecting speech. Is all of the sounds in speech are relatively the same, especially in the same language. But a car horn sounds significantly different than a doorbell or someone knocking on the door. And so this really allows us to have much faster reaction times and also do a lot of the processing on the edge, so on the device itself, without having to send the data anywhere else. This is actually really great, and we can think about ways in which robots can interpret and use this information. And just as a thought experiment, this is a one of the Starship, essentially like water coolers on wheels that drive around a campus. I forgot the university that they're driving around in. But it's basically a startup which has these sort of autonomous robots that drive around and do delivery on campus. And sort of, if you can hear certain classes of sounds, so this might be people arguing or like ambulance, maybe there's one dog, there's children in various sort of group sizes, or maybe there's traffic. And the question really is, how can we imagine this to be useful for these robots? I mean, traffic can be very obvious, right? It's like, oh, if you can detect that there are lots of people, you avoid them, because then you don't have to do less navigating. You can maybe go a little faster. But what do you do if there's like an ambulance or a dog? If you just hear the dog bark, maybe it's not even at you or someone else. But still, this information can yield a lot of sort of influence on your behavior and things on how to behave and move. So really the question is, how can we come up with these ideas and think through how does the sound that we show on the left side, so this is, here we're showing a list of different sounds and what it could imply a robot to do. So if there are children playing, you should maybe drive slowly, especially if you're in an autonomous car. You can detect whether or not you are around children very easily, because they often will make a lot of noise. If there's a dog barking, you could try to avoid or approach the dog, depending on what kind of robot you are. For an ambulance, obviously wait until you can see it. Again, this is sort of an autonomous vehicle context. But if you, for example, are if you're a robot that is in much more in a social context, at a social gathering of any sorts, and you detect that people are arguing, and you realize maybe that the robot can detect sort of a level of aggravation, you could offer distractions or avoid that area. And if music is playing, you could try to either be quiet or match the pitch with your motors as well, etc. Like, there are many ways in which you can sort of adapt and react to that. And actually, there's the last sentence where sort of you detect a sound and then you change your own acoustic sort of behavior and like input into the scene. It's very close to sort of what we were trying to convey in this workshop, where on the entire tutorial, where really the idea is to make sure that not only can you now listen, but like the way that you move also impacts the way that you are perceived, and especially the way that you make sound. And so all of these things should be considered in combination. For this workshop, Wendy has designed a couple of interaction design tools that you can use to think through this and sort of write down the structures that there are. We came up with basically two sets of tools. There's something called Method A and Method B. Method A is very open-ended and sort of almost use case oriented, And method B is full of prompts and questions. So if you have an idea of what you want to do, I would suggest you try to fill out the ideas around with method A. If you have a bit of a hard time understanding of where to use this, method B will give you lots of questions to answer, and like with that and a combination of those things, you can then come up with ideas too. And so the interaction design tool that I will discuss in this presentation now is method A, because it needs a little bit of guidance. Method B is very much self-explanatory. You can find both of them in the same PDF. They're just on different pages, and the PDF is hosted on the Google site where we host all of the information from the tutorial. So basically the idea is for the method A is to think about 4 distinct things. First is a setting, which sort of comprises who is in that setting, what is going on, when is it happening, where physically located, and why is it happening, and why is this sort of all of this important. And then you basically, out of this sort of context that you describe in the setting, you can then go to the second column where you describe what to detect, right? If we want to detect these things that we describe in the setting, what are the things that we need to detect? We can describe how to react to the detected sounds, and what are the desired outcomes that we would want to have from this. And this is we also have an example, and this is how do you make sure that your kids wash their hands when they go to the restroom. And so who is involved? Someone's kids. What needs to happen? Well, the kids need to be reminded to actually wash their hands whenever they use the restroom or after using the toilet, where it's in the bathroom. And why is this important? Well, this is sort of teaching basic hygiene. And it's difficult, like, what is to detect there? Well, whenever someone uses the toilets, but also the absence of sort of hand washing and or the absence of toilet flushing. So these are all sounds that maybe are somewhat similar, but I'm sure the system would be capable of distinguishing between the 3 types. Then we go to the third column, basically how do you react to it. In this case, it would be straightforward. You could do an audio reminder, you could have a display, or some sort of reminder to the kids to actually do the basic hygiene steps. And so it could be an audio reminder to wash their hands, or it could be an audio reminder to flush the toilet. And the desired outcome is that the kids actually do these things and learn basic bathroom hygiene habits. And then sort of besides sort of like this is sort of the previous slide really described the use case of the system. And then the next step would be to think a little bit more about sort of what kind of data is needed, what are the sort of things you need to detect and the difficulties of detecting them. And then how can we actually simulate the interaction to see whether it works, or how can we simulate the interaction to generate the data. And just to show what we mean by these things, here's again the example. What's the precondition? Well, they just went to the bathroom. And it's important that this is like the kids. You don't need to remind actually the adults who go to the bathroom to also do this. And so the question, how do you actually distinguish between the two? And so here what we would want to understand from the positive and the negative example, sort of where does water actually is being poured? Is it in the sink? Is it in the toilet? In the shower? These are all of the distinguishing sounds. Is sound being used? And what other bathroom sounds are there that could negatively affect our capability to detect it? So then the next step, once you understand sort of what the obstacles are and sort of what kind of data you need, you could think about how do you actually simulate it. One way of simulating that someone is using the restroom is basically pouring water just into the toilet and then not washing and not running the faucet or flushing the toilet, or just run the sink, to understand whether or not the system can actually distinct the different sounds. And just generating these sounds is, you can just record them. Now we'll talk a little bit about the sort of technical side of things, and this is a bit of a step forward, but this is basically a quick overview of how we actually do the sounds analysis. And what I'm showing you right now is a spectrogram. It's a spectrogram of a dog barking, and but basically what we're doing is you can see sort of it breaks down any sort of sound into a picture, and it separates out the different frequencies into a picture over time, so you can see clearly how the howling of the dog happens. And this really is good if you want to understand sort of the structure of a sound, because like an air conditioning will look very different than speech. And it's a very powerful method to detect these different sounds. I will not go into too much technical detail here, much more than this. I think the only thing to know is that there are instructions here on how to use the system, and I will upload make another video specifically focusing on the technical, on the way with which the system is being, the way in which we're using this system. So for today, or for the after sort of this lecture, I would encourage you to go through the active listening worksheet and then go on to the consequential sounds lecture. Unless you're really interested in the technical parts, in which case there are links already on the Google site to go to the GitHub repository and to the wiki page of the GitHub repository where we have most of our data stored. That was it. Thank you so much for your attention, and please always remember, join our Discord, ask questions, and then I'm there to also help you.